see how to do this. You know, you're having this desired state here as 7 plus 1/2 n, and you're already given that, you know, -2 is in between -1 and, n is in between -2 and -1. See, this is given here, okay? And you want this thing here, right? 7 plus half of n, right? So what I can do here is I'll try to make it, you know, I'll try to make this n as 7 plus half of n. What I can do is I'll just multiply half to both everything, multiplying 1/2 to everything. You will get 1/2 multiplied by -2 is less than 1/2 multiplied by n is less than 1/2 multiplied by -1. You'll get, you know, 2 times 1, 2 times -1. There'll be -1 is less than half of n.
Can you pull it down? I can't.
Yeah, sure. I will. 1 second.
I'm sorry, pull it up, not pull it down. Pull it up.
Now are you able to see that? You're able to see it now?
Oh. I was looking at the whiteboard. I'm not on the Zoom, so I can move it myself.
Okay.
Okay. Okay, see it now.
Okay. So
okay.
I'll rub it again. I'm saying that we are already given that -2 is less than n and n is less than -1, and our desired state is 7 plus half of n, isn't it?
Yes.
So we'll try to convert this n into 7 plus half of n and see what will be the answer. So for converting this, we'll first see what is in multiplication or division with n, and that is 1/2. So I'll try to multiply 1/2 to everything. So multiplying 1/2 here, 1/2 here, and 1/2 here. So I'll get -1 is less than half of n is less than -1/2, right? Because -1 multiplied by half is -1 by 2, 1 divided by 2, right?
Yes.
And for that, and for after this, you're having 7. You have to add 7 to everything. So adding 7 to everything, you know, adding 7. So you'll write 7 plus -1 is less than 7 plus half of n is less than 7 plus -half. So this will be 7 plus -1 is 6, is less than 7 plus half of n, that is less than, how much is 7 minus 1/2?
6.5.
6.5. So this is in between 6 and 6.5. Now what we have to do is we have to round this to the nearest whole number. So which whole number is closest to 7 plus half of n?
7?
7.
No, 6.
6, exactly, because it is in between 6 and 6.5. So for example, let us take it as 6.3. 6.3 is closest to 6, not 7, right?
Yes.
And that is why 6 is the answer. But
Okay.
can you quickly tell me what we did in this?
Yes, I can. Okay.
Yeah.
So we took the 1/2 multiplied by n and multiplied it with the -2 in the n, like the whole equation. And then we added the answers we got with 7. Then we got 6, and then is less than 7 plus 1/2 n is less than 6.5. Then we went to the nearest whole number, which was 6.
Right. So we have to convert the, you know, inequality into the desired state which we are interested in. So that was 7 plus half of n. That's why we did, you know, some manipulations, some multiplications and divisions to the given inequality to get 7 plus half of n. and that's having the value in between 6 and 6.5, and the question is telling you which is the nearest whole number, and that is 6, and that is the answer.
Okay.
Okay, then what about question number 5 is right. What about question number 6? You can do it, I think.
I did number 6.
I'm not able to see the answer.
Either, but I remember doing it. It's C.
Oh, it's C. Question number 6, option C. Let us see whether this is right or wrong. So you're having the number line in which, let us take the unknown as x, which is already in the question. X has to be greater than or equal to 4, right?
Yes.
And x has to be less than -2, because it's hollow circle.
Yes.
So it can be either this or that. It's an or. It's not giving you and.
Oh.
So
Okay.
which option?
8.
Yes.
So if they're like separate like that, it's an or?
Yes, exactly.
Okay, that makes sense.
Because they are indefinitely going, one is going to the right side, other is going to the left side. But if this would have been the case of that question which we did, that one which was, I think it was question number 3, option D. That was and condition, and it's already in the question, it's and. Right, that was and condition, because both the inequalities has to be, they have to be both followed. So that's why this was the and condition. And in question number 6, you're having option C and D as the and condition. Okay, in question number 6, you're having option C and D as the and condition. A and B is the or condition.
Oh, okay, yes.
Question number 7, can you now try this? Because we tried one question related to this, like it was near to this.
Is it
Yes?
number 7? Is it like number 4?
Number, one second. Number,
It's possible.
a type of, yeah.
Oh, okay. Okay, I think I know it. Okay, hold on.
Okay, try it.
Maybe.
It's just simplification. Like, you're having equations. What you were doing in that, same thing needs to be done here.
Why am I writing slant? Oh my geez. Okay.
And you know
It's
that when
8.
you, okay, Let us try it again, because you know that when you multiply with a negative number.
No, it's negative 8. X is greater than or equal to negative 8. Hold on, hold on, hold on, hold
Greatest
on.
possible value of x, right?
Is less than or equal to negative 8.
Yeah, but what can be the greatest possible value? Give me one number. Is it 8 or negative 8? What it is?
Negative 8.
Okay, let us do it again. 1 over 4 x minus 1 is less than or equal to negative x plus 5. What you did is you added x to both sides, right?
Yes.
Then how much will be 1 over 4x plus x? A type of 1 over 4 plus 1 in terms of numbers.
Oh, dang it. 4 plus 5 over 4.
Yes. So it's 5 over 4x minus 1 is less than or equal to 5. Adding 1 to both sides, you will get 5 over 4x is less than or equal to 6. And then multiplying with 4 over 5 to both sides, you will get x equals 6 times 4 is 24 over 5. X is, sorry, not equals, less than or equal to 24 over 5. That means x can have the highest value as 24 over 5, and that is the answer.
Mm-hmm.
So your mistake was in calculations again.
I knew what I was doing. I just did my math. Got it.
Yeah. Question number 8. Can you try question number 8?
Okay. Hold on.
For absolute value inequalities, I have told you if it is less than or equal to how to decode it, and if it is greater than or greater than equal to how to decode it.
Can I plug in any integer to see if it works?
Yes, you can plug in that also, because you have to see one of the possible values of n. But n should be an integer.
Okay, hold on.
And you're having absolute value here also, like this.
Wait, 2 is an integer.
Yeah, you're right. 2 is working, I think, right?
Mm-hmm.
So 2 is also the answer to this question. That's right.
Okay. Okay. Good.
Yeah, 2 is also the answer. But we should also be able to do it if you're not able to plug in the answers and you're stuck. So what you will do, you should be able to decode this, absolute value inequality. And I told you, if you're having less than or equal to absolute value inequality, then what you will do is you will write one inequality as 3 over 4n minus 2 is less than 1. And, always there'll be and here. And 3 over 4n minus 2 is greater than negative 1 for this absolute value. So it will be like this. And then we can solve it, adding 2 to both sides.
I thought absolute values can't have negatives.
Yes, absolute value can't have negatives. So you will rule out the first one. It's the second one, sorry. You are correct. Absolute value cannot be negative. Okay. But absolute value cannot be negative. But the decoding can be negative, isn't it? You are
What do you mean by decoding?
uh see, I'm not writing absolute value. If this would have been 3 over 4n minus 2 is greater than, like it is absolute value here. Absolute value of 3 over 4n minus 2 is greater than negative 1. So then I can say this is wrong. This is not possible. See.
What happened to that? Like, why did we take away the absolute value, like thingy, the sign, the little line?
Because absolute value is, inside
Oh,
absolute value, you're having n, so it can have, two values or more than two values, which will be
well, hold on.
satisfied.
So let me get this right. Okay, so this can have a negative, right? But this can, because it's like the opposite, so not really exactly absolute. That doesn't apply.
Yes, there's no absolute value sign here, so
Okay.
we don't have to care
But
about,
this
like,
one right here, this one can't have a negative, right?
not like that. If you're having absolute value sign, this sign here like that.
Well, where did the sign go? It's over here on the problem.
Yeah, it's in the problem. How do you solve this absolute value sign? Like, how do you solve absolute value inequalities or equations? What do you do at that moment? See, I'll give you an example here. If you're having 2x plus 7, absolute value of 2x plus 7 is greater than or equal to negative 1, you can clearly say that since absolute value cannot be negative 1, so it is wrong. So that's not possible. But if I'll give an example here as absolute value of 2x plus 7 is greater than or equal to 1, right? Like, how do you calculate the value of x, which satisfies this absolute value equation? You can write as 2x plus 7 is greater than or equal to 1, right?
Oh, so you took away the absolute value.
Yes, I took away. Yes, I took away the absolute value to solve it. So one option is this, and the second option will be 2x plus 7 is less than or equal to negative 1. There are two options. There are two answers to this absolute value. That means x can have two values, which will be satisfied by this absolute value inequality. I'll do it for a simple number, because this is a very important concept. If you're having anything here which is not clear, then that can create problems. For example, you're having x, okay, absolute value of x is equal to 2. Okay, absolute value of x is equal to 2. Then I will decode it. I will write it as, that means x can be either 2 or x can be negative 2. Why? Because when you plug in the value of x as 2 here, you will get absolute value of 2 is 2. And when you'll plug in the value of x as negative 2 here, you will get absolute value of negative 2 is again 2. So there are two answers to this absolute value equation. Either it can be 2 or it can be negative 2. Is it making sense?
Yeah. I remember we learned this.
Yeah, okay, great. So now let us move a little bit one step forward, and let us see absolute value of 2x plus 3 is equal to like 5. What should be the value of x which will be satisfied? Like, how we have to calculate the value of x. But this is not the simple equation. It is absolute value equation. That means it will be having two values. One will be 2x plus 3 is equal to 5. Subtracting 3 to both sides, you will get 2x equals 2. Dividing by 2 to both sides, you'll get x equals 1. So x will be, the answer to this. But not only x, there will be one more answer. And that will be done by 2x plus 3 can be negative 5. Because when you'll see the answer of x here, subtracting 3 to both sides, you'll get 2x equals negative 8. Dividing by 2 to both sides, you'll get x equals negative 4. Plug in the value of x is negative 4 and you will see that it is also working. So you're getting the value of x is 1 and the value of x is negative 4 to this absolute value equation. So if we'll plug in the value of x is negative 4, you'll get 2 times negative 4, that's negative 8. Negative 8 plus 3 is negative 5. Absolute value of negative 5 is 5.
Yes.
Right? So this was about equations. Now let us extend this thing to the inequalities. So let us take this inequality which is in the question. And this is absolute value of 3 over 4n minus 2 is less than 1. That means you'll be having the value of n as 2 values. One will be 3 over 4n minus 2 is less than 1. It will be calculated by this. And the second one will be 3 over 4n minus 2 is greater than negative 1. And there's an and here, always for the less than or less than equal to sign. So whenever you're having less than or less than equal to sign, you will put an and to the two inequalities which you will make. And if there's a greater than or greater than equal to sign, you will put an or in between the two inequalities.
Okay.
So let us try to solve these two inequalities and see what we're getting for n.
Less than and less than equal to equals or.
Less than or less than equal to, that is and. Okay, less than means and. Greater than or greater than equal to means or.
Okay, I'm writing that down.
Yeah, write it because these are very important things. That's why I told you keep some notepad or something, so that whatever the things are coming here, you're able to write them and revise them. So adding 2 to both sides to this inequality, you will get 3 over 4n is less than 3. And multiplying by 4 over 3 to both sides, you will get n is less than 4. And 3 over 4n minus 2 is greater than negative 1. So you'll add 2 to both sides. You will get 3 over 4n is greater than 1. Multiplying by 4 over 3 to both sides, you'll get n is greater.
Question.
Yes.
Do you know the one we're doing now? Why did you flip the sign?
Yeah, fine. So I'll write it here. Absolute value of 3x plus 2, just leave this thing. I'll do the, new thing here, is less than equal to 4. Okay. Absolute value of 3x plus 2 is less than equal to 4. We have to see which value of x can satisfy this inequality, right?
Yes.
So we have to calculate that x, isn't it?
Mm-hmm.
And for calculating that x, what should we do? We have to
take away the absolute value.
Yes, we'll take away the absolute value. But inside absolute value, whatever the thing is, that can be positive or that can be negative. For example, this 3x plus 2, that can be positive, and this 3x plus 2 can be negative. Because, if this is negative, still that will come out to be positive because we're using absolute value sign. You understand?
Mm-hmm.
And if this is positive, then it is obviously positive. Because absolute value is going to give you positive for the positive and positive for the negative also.
Mm-hmm.
Right? Now, those two numbers, so see, if we don't flip the sign, if we'll write 3x plus 2 is less than equal to 4 and 3x plus 2 is less than equal to negative 4, right? You are saying this thing, that why do we flip the sign, isn't it?
Yes.
So let us try to solve it. Subtracting 2 to both sides, you'll get 3x equals 2. Dividing by 3 to both sides, you'll get x equals 2 over 3. And for this, subtracting 2 to both sides, you'll get 3x is less than equal to negative 6. And dividing by 3 to both sides, you'll get x equals less than equal to, x is less than equal to negative 2, right? So it's less than equal to, less than equal to. So what's happening on the number line? You are using the value of x as a number which is less than 2 over 3. That means it is less than 0.6666. Let us mark it as it is 0 here. That is marked as 0.66. And less than equal to negative 2, let us mark it as negative 1, negative 2, like this here, right? So whatever the values of x which are less than negative 2 and which are less than 0.6666, they will all satisfy this inequality, isn't it? Because I told you you had to, yeah, whatever the values of x which are less than or equal to 0.66,
Yes.
and which are less than or equal to negative 2, they are going to satisfy this inequality.
Yes.
Okay, let us try it now. Let us plug in the value of x is negative 1 and see whether that's going to work or not. So how much you will get for plugging in the value of x is negative 1? Because that is also in that range, isn't it? X has to be less. Yeah.
It would work because it would be negative 1 less than equal to 4.
It's not working because you know you're having sign as less than equal to, and you're having 0.66. X should be less than 0.66, okay, towards left, and x should be less than or equal to negative 2, and that's again towards left, right? So that means all those numbers which are less than 0.66 are not working here. Okay, why they are not working? Because you are taking both the inequalities as less than equal to less than equal to. No, not sure, not clear, right? You're not clear about it.
I think I get what you mean, but I feel like all of this made it confusing. But I'm guessing is 3x plus 2, when you do 3x plus 2 is less than equal to negative 4 to solve, like, you know, the other, that's why you switch it, you flip the sign.
Yeah, you're getting it right. That's right.
Yeah.
But
then you gave all this, so then I got confused.
Okay, so let us put it in this way, that 3x plus 2, absolute value of 3x plus 2, when that is less than or equal to 4, that means 3x plus 2 is either less than equal to 4, not either, it is less than equal to 4, and 3x plus 2 is greater than or equal to negative 4. So this is what it means by putting in absolute value sign with a less than or equal to inequality. This is what it means. This is what it is, what it really is. It is either, you know, less than or equal to it is either less than or equal to 4, not either, it is less than or equal to 4, and it is greater than or equal to negative 4. Here you are getting bounded curve. Try to understand this thing. 4 to negative 4. That is the only solution. All those numbers which are in between 4 and negative 4, that is the answer to this.
So you're trying to tell me we have to flip it because if we didn't, it would be less than 4 and less than
Yeah,
negative.
yes, exactly. It will be unbounded. It will be like,
Okay, it'll only be going towards the left and they don't have, okay, I got it.
and those will not be satisfying this inequality,
Got it.
right? But at the same time, if it is greater than or equal to 4, if 3x plus 2 absolute value is greater than or equal to 4, it's having a different scenario. It will not work if you will, put it and here. It will only work, it will put or. All those numbers will be taken into consideration, which will satisfy this inequality when you will put or for the two inequalities. It means it will be 3x plus 2 is greater than or equal to 4, or 3x plus 2 is less than or equal to negative 4. And in this condition, the curve will be unbounded. That means those values which will come in this, they will be greater than or equal to 4, greater than or equal to 4, going towards right, less than or equal to negative 4, less than or equal to negative 4, going towards left. All those numbers which are in between 4 and negative 4 will not be satisfied by this inequality. All those numbers which are in between 4 and negative 4 will not be satisfied by this inequality. That is why we put an or here.
And or would look like a dot and the one's going on one side and the other one's on the other one.
Yes, exactly. A dot from on one side and the other one on the other side, opposite to each other. And the thing which is in between them, that will not be satisfied. Let us try. Let us see 0, because 0 is also in between negative 4 and 4. Let us plug in the value of x as 0 and see whether that works here or not. Is it working here?
What is working?
Like when you plug in the value of x as 0, is this inequality holding true?
No.
3 times 0 plus 2, that'll be 2, and 2 is not
No,
greater
it's
than equal
not.
to 4, so it's not. So if you will take and, that'll also make it wrong. If you will take, if you'll not flip the signs, that'll also make it wrong. You understand? So practically, when you see the number line, you're having these two things here. Or the question can come in this way: 3x plus 2 is greater than or equal to 4, or 3x plus 2 is less than or equal to negative 4. Convert this into an absolute value inequality. So you'll put the number line, okay? You'll put the number line. I'll write it here. You'll make the number line. This is 0. For example, this is 4. This is negative 4. And let's put x is greater than or equal to 4 and x is less than or equal to negative 4. So you'll be having, x is greater than or equal to 4 means this is going towards the right, and x is less than or equal to negative 4, this is going towards the left. And you have to make an inequality, right? That means you have to make an inequality. X, absolute value of x, is greater than or equal to 4. Why? Because when you will convert this into an inequality, you will get x is greater than or equal to 4, or x is less than or equal to negative 4. Then only it will be satisfied. Right? So you should have, you should be able to do the answer in both ways. If you're having two inequalities, you should be able to convert them into an absolute value inequality. And if you're having absolute value inequality, you should be able to convert them into two inequalities. So in this case, absolute value of x is greater than or equal to 4. You have converted that into x is either greater than or equal to 4, or x is less than or equal to negative 4. Now, if you're having a question, that the value of x is in between negative 4 and 4. So what can be the absolute value inequality at that moment? Simply same thing, but less than or equal to 4, simply. absolute value of x is less than equal to 4. When you will decode it, you will get x is less than equal to 4 and, okay, and here, and absolute x is greater than equal to negative 4, greater than equal to negative 4, right? So x has to be less than equal to 4. So from 4, you will go towards the left. And x has to be greater than equal to negative 4. So from negative 4, you will go towards the right. And you will stop from negative 4 to 4. You'll not go beyond that. You'll not go more than 4. You'll not go more than negative 4. Right?
Yes.
Maybe it will be a little bit confusing, but if you will get this, like how to decode, how to convert this, then it'll be, you know, all the questions of inequality will be,
I get the mixed graph is and.
Mm-hmm.
The two dots and separated is or.
Yes. Yes. So I'll give
I
one
got that
question.
part.
If this is 3x minus 7, absolute value of 3x minus 7 is less than 4. So how will you convert it? What you will write? What will be the two inequalities?
Well, I can't write because you're on Zoom.
Oh, okay. You can annotate, you can write still, you can write, you can annotate and then write. You can tell me the inequalities and whether in between it'll be and or.
Why does... Hold on. It won't draw. 3x minus 7 less than 4. And then 3x minus 7 is greater than negative 4.
Yeah, but what is in between? Is it and or? For less than
It's
or less than
it's and.
Yes. For less than or less than or equal to, it's and for a greater than or greater than equal to, it is or.
Or.
So it is and here. So can you make it on the number line? Can you calculate the value of x in both the inequalities and write it on the number line?
Yeah, I can. Oh. Okay.
So how much is the values? How much are the values?
X is greater than 1 and x less than 11 over 3.
Yeah, that is nearly how much? 3 times 3.
Good question.
3 point something, right?
3 point, yeah. And then this is 1 and this is 3.
Okay.
Yeah, we're just gonna say that's 3.
Yeah. And they both are having hollow circles, right?
X is less than 3. So here it is. It's like this. This.
Yes,
And then
exactly.
like this.
Yes. Yes, correct. So for and, you will always be having bounded curve, you know, starting from one point, ending at another point. That's it. And for the or, you'll be having unbounded, you know, starting from one point and indefinitely going somewhere, and starting from another point and indefinitely going some other where or some other place. right? So I think now you will be able to try, do them, do those questions of inequality.
Yes.
So I have put in all the questions. If you get, time, but not before the class, because maybe you might be in rush at that moment. So you'll not be able to focus 100%. So if it'll be like after
Wish I had time before then.
what?
I don't have time tomorrow because I have a game and I won't be home back till 10.
Oh, okay.
Only time will be tomorrow after I come home at 5. So, and our class starts at
Mm-hmm.
6 tomorrow, right? For me?
Mm-hmm. For
Okay.
no. If you want it at 7, then we can have it at 7.
Not tomorrow, I'm sorry, Wednesday.
Yeah, if you want it at 7, then we can have it at 7.
Yeah, can we have it at 7?
Yeah,
It
definitely.
works. It just works better.
7 p.m. Fine, we'll have it at 7 on Wednesday, right?
Yes.